Hello everyone. The problem is a series RLC circuit consists of a resistance of 1 kilo ohms and an inductance of 100 millihenry in series with the capacitance of 10 picofarad. If 100 volt is applied as input across the combination, determine first is the resonant frequency, second is maximum current in the circuit, and third is the Q factor of the circuit, and last is half power frequencies you have to calculate. Okay, now first we'll write what all things are given in the problem here. So what is given here? Resistance is given, that is 1 kilo ohm, that is equal to 1 into 10 raised to 3 ohms. Next, inductance is given, that is 100 millihenry. So 100 millihenry, that is equal to 100 into 10 raised to minus 3 Henry. Next, you have what? You have capacitance 10 picofarad. C is equal to 10 picofarad, that is equal to 10 into 10 raised to minus 12 farad. Then you have voltage V is equal to 100 volt. What you have to find out first? You have to find out the resonant frequency. So first is resonant frequency, which is given by F naught is equal to 1 divided by 2 pi square root of LC. So you can write it as 1 divided by 2 pi square root of L is what? L is 100 into 10 raised to minus 3 and C is 10 into 10 raised to minus 12 under the square root. So when you solve this, you get it as 159.15 kilohertz. This is the value for F naught. Okay. Next, second, you need to find out the maximum current. So this maximum current I naught, it will be flowing in the circuit only at the resonance. Therefore, maximum current I naught is equal to V by R. V is given as 100 and R it is given as 1 kilo ohm, that is 10 raised to 3. 1 into 10 raised to 3. So we'll get this as 0.1. Therefore, I naught is what? I naught is 0.1 amperes. Okay. Next, third, you have to find out the value of Q naught factor. Okay, that is given as Q naught is equal to 1 divided by R square root of L by C. So substitute 1 divided by 1 into 10 raised to 3. Then square root of L is how much? 100 millihenry. 100 into 10 raised to minus 3. And C is 10 picofarad. 10 into 10 raised to minus 12. So when you solve this, you get it as 100. Therefore, your value for Q naught is 100. Okay. Now, next you have to find out the value for bandwidth. So fourth is what? It is bandwidth. Bandwidth, it is given as 2 delta F is equal to R divided by 2 pi L. Okay, it is R divided by 2 pi L. Now you want the value for delta F because we need to find out the half power frequencies for which we want the value for delta F. Therefore, we can write it as delta F is equal to R divided by 4 pi L, that is 1 into 10 raised to 3 divided by 4 pi into 100 into 10 raised to minus 3. So you will get it as 795.77 kilohertz. Okay. Now, next you want the value for half power frequencies. So first we need to find out the lower half power frequencies, okay, which is given by F1 is equal to F naught minus delta F. that is equal to 159.15 into 10 raised to 3 minus 795.77. So you get it as 158.35 kilohertz. Okay, then next you have upper half power frequencies, that is f2 is equal to f naught plus delta f. So it is 159.15 into 10 raised to 3 plus 795.77, which will get it as 159.95 kilohertz. Okay, so this is the formula to calculate lower half power frequencies. This is to calculate upper half power frequencies, and here this is for bandwidth, from which you need to get the value for delta f. This is the formula for calculating the Q naught. Okay, this is for maximum current I naught, and this is your resonant frequency f naught. Thank you.